This is October, November 2022, paper 1-2, October, November. Okay, so what is a physical quantity? So physical quantity के लिए बिल्कुल basic O-levels वाला question है. It requires you to understand that what is the condition for a physical quantity. So it needs to have a magnitude, plus it needs to have a unit. For example, if I say mass is 50 kg, then this is the magnitude and 50 kg is the unit. And this quantity is representing mass. So flavor are basically in quarks. It's neither a physical quantity nor it's something that we can measure still. Or does it have a unit? No, it doesn't. Kelvin is a unit of temperature, but it's not a physical quantity completely. It's just a unit. But for a physical quantity, we need both of them. Minute is again a unit of time. So this will be rejected, this is rejected, this is rejected. So by hit and trial, or at least by elimination, we get to point D. Now potential difference, of course, if I write down 5 volt, I can have a number and a unit. And this is a physical quantity that can be measured. All right, so moving on to question number 2. This is primarily a test of prefixes, whether do you know them or not. He says, can it be represented in kilowatts? Yes, it can be, because we know that mega has a power of 6, and we want to convert this into kilowatts, which has a power of 3. So I can open this up as, at least by basic mathematics, like this. This 1 10 to the power 3 will be converted into kilowatts, and 1 10 to the power 3 will stay with it. So the closest option is option C. Question 3 requires that what is the percentage uncertainty in the extension? You can always pause the video and try the question on your own. So in this, we realize that if you want to find the uncertainty in expressions of addition and subtraction, for example, what 2 quantities are being added or 2 quantities are being subtracted, their uncertainties, their deltas are always added together, no matter how you solve the equation. Now, since this is about extension, I think, or at least I accept that this is going to be a difference equation. I'll have to deal with the difference of values. So he says the final length is this, the initial is this one. So extension will be found by the final length minus the initial length. Now, what you're going to do, you're going to subtract the true values according to the formula. So that will be 250 minus 225. You have calculated the extension, but what about the delta extension? What about the absolute uncertainty? Or what about the percentage uncertainty? As I explained earlier, for addition or subtraction, the uncertainties of both quantities are going to be added together, no matter if it's expression of addition or it's expression of subtraction. So this will be 2 plus 2. These were their errors, so they are simply added together. So what do I get? I get 25 plus minus 4 millimeters of error in my measurement. To find the percentage uncertainty, I divide the uncertainty or absolute uncertainty with the actual value, multiply this with 100, and I get a 16%. Be advised that if this had to be found by an addition formula, then the uncertainty would still be added together. As I've explained earlier, it does not matter. Please keep that in mind. Okay, so what is the difference between scalar? This is a very straightforward question. I'm not going to discuss this because you can see that very clearly over here. Question 5. This is a bit tricky and a big back to the basics. If you are unable to relate to the question in terms of basics, then it will be a difficult question for you. You see, the track is circular. Okay, no problem. A constant speed of 0.5 meters per second with no direction. That means I can use this to find out the circumference or the total length of path at least. He says it passes a point when the track starts. Okay. So at t equals to 0 starts the journey and takes 40 seconds to travel once along the track. So he is going to exist at this point at 2 instants. First, when he starts the race, and second, when he comes back to this point. So I can at least find the circumference or the total length of path by simply multiplying speed with time. According to the formula, speed equal to distance over time. If I want to find the distance, I can do that. So 0.5 multiplied by 40 gives me an answer of 20 meters, which means that the length of path is 20 meters. Now, the next question he asks is the magnitude of velocity between t0 and t20 is v20. Now, I can relate to this answer that if this is a constant speed, then at this point, it would have reached after 20 seconds, have passed by, and in the next 20 seconds, he would have gone by to the next half of its journey. Then he tells me that the magnitude of average velocity between t0 and 40 is v40. Okay, fine. That would have been at this point when it came back to the position. He says, what are V20 and V40? You see, we need to realize very head on and very straightforward that V40 is going to be 0. Why? Because if we are talking about velocity, we know that velocity is equal to displacement divided by time taken. Now, displacement, luckily or fortunately, becomes 0 if your starting point and if your ending point becomes the same thing. For example, if you go to school, come back to your house, your starting point is your house and your ending point for the day is your house as well. So your displacement effectively can be considered or will be considered as 0. So in short, starting and ending point, if they are same, the displacement will be 0. So velocity of 40 should be 0. I will cancel option B and D, will not even consider them. Now, what to do about this V20? You see, V20 requires that this should be our displacement. So this will be our D20 displacement, and time, of course, is already given to us as 20 seconds. But how to find this distance? Now, if you want to find this distance, of course, we need to find out the radius, because it's exactly in front of this. So this will be actually 2 times radius, or this is basically the diameter, however you want to say this. So I'm going to use the circumference as 20 meters equals to 2 pi r, right? Now, when we do that, we find that the radius comes out as 3.2. This comes out at 3.2 meters. Now, we know that the distance or the displacement from this point to this point will be 2 times the radius. So multiplying this with 2 gives me 6.4 meters. Now, this is my displacement from the starting point, and I know that I took 20 seconds to cover this. So divide this by 20, I get 0.318 meters per second, which is 0.32. So my correct answer will be option A. Moving on to question number 6. This requires a bit of imagination, but let's see. He says that the velocity of the object is given to us in a straight line. Now, why does he enforce that it's a straight line? Because he wants you to think that it's not a circular motion case. There is no acceleration or centripetal acceleration involved. That's why he wants to say this. Plus, in straight line speed, at least velocity becomes equal to speed because the direction is not changing. So distance becomes a displacement. To make matters simple, at least. Okay, so he says which graph could represent the displacement s of the object, t equal to 0, t equal to 1. You see, since this is a displacement time graph, in every option, I can see that the gradient, or at least the slope of all these options, is going to represent velocity. How do I know this? Because I know that the gradient is divided by y divided by x, and on y I have s, which is displacement, and on x I have t. So displacement over time is actually velocity. So what's happening to the system, or what's happening to the object right now, is that its velocity is becoming 0 at certain instants in time. So if the velocity is 0 at certain points, then the gradient should also be 0 at certain points, at least those locations. So the option A, let's verify option A. At the very beginning, when the velocity was 0, the gradient appears to be 0 as well. When the velocity reaches at midpoint, the gradient also appears to be 0 again. When velocity reaches the last point at time t, the gradient is 0 again. So this appears to be the closest graph. But let's compare option B. You see, at the very beginning, when the speed is 0, at this point, the gradient should be 0. But in B, we see that the gradient has a positive value. So this will be rejected to begin with. In C, again, initially the gradient is a non-zero value. It will be rejected. Now, when we come to D, we realize that at the very beginning, the gradient is 0, right? So this looks like a promising option, but let's move on. When we go to the first part, or at least complete the first part of the journey, we realize that there should be, at least in terms of this point, when the velocity is maximum at this point, at this time, the gradient should have been maximum. But when I go to this point, I realize that the gradient is 0. So it is a graph of something else. It's not for this one. Okay. So option D is also rejected. Option A will be the correct answer. Now, another way to look at this, which you may not find in some online past papers as well, is to visualize it in terms of displacement. You see, the area under the graph represents displacement, right? Now, since the velocity is positive, the displacement will also be positive. Or you can say it will pile up, it will be added together as you're finding the area under the graph. Now, when you start moving towards this side of the graph, you realize that the velocity is negative, which means that the object is trying to come back or is going to come back. So the starting point and the ending point should have a zero displacement, right? So at the very beginning, the area seems to be gathering around. It seems to be covering up or giving you a larger and larger value. And similarly, it starts giving you smaller to smaller value because now you're coming back. So your displacement at a certain time is going to start decreasing. At the very beginning, it was increasing, but after that time, it starts decreasing. So there's another perspective to look at this, at least visually speaking. Question number 7 requires a bit of algebra and graphical representation as well. He says that there is a train moving at 10 meters per second at a constant speed, and it is going to be overtaken by another train who is going to start from rest, for example. It starts from rest but has a constant acceleration. When are they two going to overlap or at least overtake each other? You see, this is a problem of an area question. So if we draw a velocity time graph, I have a train that moves at a speed of 10 meters per second, and let's say that this is that time t when they are going to overlap each other. But the second train starts from 0, but it has a steady gradient of 0.5 meters per second square. Because we know that distance time graph or speed time graph's gradient is an acceleration. This is that time t, the common point where one of the train is going to overlap or at least overtake the other train. Their total area should be the same. This is the premise. So area by train, at least the train 1, should be equal to the area covered by train 2. So area for the first train is going to be very simple. It's actually this simple rectangle, which will be 10 multiplied by t. The area of the second triangle requires a bit of manipulation, a bit of understanding that we could have found this by simply taking that 1 over 2 base into height, but we're not sure about the final velocity, and we're not sure about the time either when they are going to overlap and what will be its velocity. We're only having the information about same distance or displacement. So we're going to use the equation s equals to ut plus half at square. The initial was 0, so this factor becomes 0. Since this is equal to displacement, I can replace half at square in this position. So area to a train 2 is equal to half, which is the acceleration is 0.5 and then t square. If you look closely, this is going to become a quadratic equation with 0.25 t square minus 10t equal to 0. By bringing 10t over there, this negative sign is going to appear. So when you solve this equation, you realize you get 2 times for t, t0 and t40. So t40 later in life, when this is going to happen, the larger value will be the time for that purpose. Question number 8 was straightforward. F acts on an object of mass m for time t. What's the change in momentum? Simply put, change in momentum we realize is actually rate of change of momentum is defined as force. Take time over there, this becomes change of momentum equals to force into time taken for the process. So very straightforward, C was the answer. Question number 9 was again a very straightforward question, no difficulty over there. He says that P, the gravity of P is, let's say, G. The gravity of Q is, let's say, 10 times G. He says 1/10. I try to avoid fractions because they involve algebraic complications. So let's not go there. Let's keep it 1 and let's keep this as 10G. Makes things easier. He says on the surface of P, the mass is 1 kg and the weight is 1 Newton. Okay, plausible. When you go to Q, what's going to happen? So mass does not change, right? The quantity of matter, the number of atoms, the number of particles will not change. But the weight of the element is going to change. The weight of the object is going to change. Since the gravity is 10 times higher, the weight is going to be 10 times higher, so as W equals to mg. If you increase G by 10 times, the W is going to increase by 10 times. So 10 newtons, with option B being the correct answer. For question number 10, I'm going to show you an animation for this to fully understand what's happening. You can take a pause and try to guess the answer yourself, and then I can explain it to you. This question is basically related to that free fall example that we used to do in O levels as well, about the parachute falling from a great height and then opening a parachute. We can relate to this graph, but we sometimes are still unable to relate it in terms of values. Let's try to relate this in terms of values. What's going to happen at this point, right? Just a moment. All right, so let's try to visualize this in terms of animation at least. Now, at the very beginning, we need to realize a few things, right? So at the very beginning, we realize that the object's velocity is 0 meters per second. Okay, it has no velocity. It does have some weight, which is in the downward direction, but the object has not started moving yet. Let's allow this object to move for a little while and see what happens, right? Let's allow this to happen. Now notice as we allowed it to move, the object has started to move, and look at what has happened. You see, not only that the speed has increased from 0 to 45 meters per second, for the sake of example, right? The drag is also increasing gradually. So from this place, we realize that drag, at least, is proportional to speed. So as the object tries to fall through air, its speed increases, and as a result, the air resistance or the drag also increases gradually. Now, there's going to come a time, as since it's still falling under the influence of gravity, notice what's going to happen eventually. This is where the terminal velocity comes into play. There is going to be a time when both vectors, at least both weight and the air resistance, has become equal. Because they've both become equal, the resultant F equals to ma, this weight minus drag equals to ma, or 10 minus 10 equals to ma. This produces 0 equals to ma. Now, since we know mass is not equal to 0, according to maths, then must be acceleration is equal to 0. One way to look at this in this way. The other way is you can see that the gradient of this graph has become 0 as well. And we know that velocity time graph represents, the gradient of velocity time graph represents gradient. It has become 0, right? Now, what's going to happen after this? Right after this point, let me erase this. So right after this, we realize that, let's play this animation for a bit longer. Now, the moment he opens the parachute, at this instant, at this very instant, he opens the parachute. What's going to happen at this point, or what has happened at this point? You see, because he opened the parachute, the drag momentarily has become greater. The drag has become greater than the weight, which was still -10, which is still the same. It's not changing. So what will this change? So according to F equals to ma, since it was the pulling force weight minus drag equals to acceleration or mass into acceleration, weight has not changed, but drag has increased. So this will cause a deceleration. This will call for a deceleration. This is why, if you realize, if you look very closely, the speed or the terminal velocity previously, you can go back and see, was 55 meters per second. Now it is decreasing. The speed has decreased. Why? Because the drag has become greater. Why? Because you opened the parachute. Let's let this run. Let's let this animation run for a while again. Now, luckily, like a chain reaction, what happens is that since because of the drag there is deceleration, the speed is going to reduce. So when the speed is reducing, since drag and speed are proportional, drag also starts reducing. Now notice, at this stage, drag was very high. It was approximately 20-25 newtons at this point. But what has happened to the drag now? It is decreasing as well, because your speed is decreasing as well. So gradually both things reduce like a chain reaction. And at the end of the stage, we will see that both weight and drag are going to become equal and setting up a new terminal velocity for these circumstances. Let's let it run. At this point, you see, drag and air resistance and weight have become equal again. Drag and weight are equal again. Now, since they are equal, acceleration will be 0 and there will be a constant velocity again, right? But we do realize that there is a time when the drag is much greater than weight so that deceleration can be produced, right? Okay. So we come back to the question. He says, in which region air resistance is much greater than the weight? Very clearly, it's C. I hope that the visualization is clear now. Question number 11. This question says that the collision is perfectly elastic. If the collision is elastic and mass is missing in the question, be ready to apply the relative speed rule. The relative speed rule. If you're not familiar with this, you can go back to the channel and watch the video of momentum, titled with momentum and relative speed trick. This is a very integral part of the of your A-level course, and if you skip this, you will not be able to solve these questions. It says that it moves 6 meters per second towards the right side and probably it's stationary. Yes. So sphere Y is stationary at the very beginning. So what would be the relative speed? The relative speed would be 6 plus 0 equals to 6 meters per second. He says that after the collision, sphere X moves with a speed of 2 centimeters per second in the same direction, which means that sphere X is still moving in this side as 2 meters per second. He says, what is the speed of Y? What could be the speed of Y, right? In the same direction. What could be the speed of Y? You see, if Y would be moving at a speed of 2 meters per second, then the relative speed will be 0 meters per second, because we know that if they're moving in the same direction, we have to take subtraction. We have to subtract both velocities. Okay, this is tried and tested, didn't work out. Let's try option B. If this was 4 meters per second, then the relative speed would be 4 minus 2. Again, giving an answer of relative speed of 2 meters per second. So, not a good answer, not an acceptable outcome. Let's try 6. For 6, it will be 4 meters per second as 6 minus 2. But if it's moving at 8 meters per second, since they're both in the same direction, I should subtract both velocities. Although they're moving towards the right side, students get confused by the direction vector taken for change in momentum or momentum questions. You see, relative speed rule is a bit different than general momentum questions. That's why I'm saying that you should go back and watch the video to fully understand how it is used. Anyways, this looks like an answer of 6 meters per second now. Before collision, it was 6 meters per second. After collision, it's 6. So D gives me an answer for perfectly elastic collision. Sphere Y should be moving at a speed of 8 meters per second in this direction to make sure that the collision remains elastic, or at least falls in the category of elastic. What is not necessary to come forces in a couple? You see, force in a couple, torque at least, forces should be in opposite direction. There should be in perpendicular distance between them. They should cause a rotation at least, right? So you can pause the video and look at the answers. Is not necessarily true. You see, they should produce a resultant. It's not their job. Their job is to just produce a rotation. They act in opposite direction is one of the conditions. They act along different lines is one of the conditions, because it's acting in this way. It is acting this way. They are acting a distance apart from each other. They have same magnitude. Yes, this is a requirement for torque. If this is 10 Newton, this should also be 10 Newtons. This is the underlying condition for torque. For a couple of forces. Question number 13. A bit tricky, but let's go ahead with this. You can pause the video and look at the question. Try to read this on your own. He says the length is 12 centimeters. The weight is 0.43. The greater part is overhanging the edge. It's okay. The good thing is he's mentioned the pivot so that we know where to take the distances from. He says that the box is at its geometric center. What does that mean? It means that the box's center of gravity is actually 6 centimeters from this point and 6 centimeters from this point. If you want to take distances from the pivot, now it's going to become easy. He says assume the forces in the boxes are in the plane of the diagram, which means that there are no other forces acting left or right, or at least out of the page or into the page. Nothing of that sort is happening. Whatever is visible on the screen is going to be taken as it is. This is what he wants you to assume. He says that what is the minimum mass of the sphere required to maintain this equilibrium? So we are supposed to find the mass of the sphere, but first we need to take its weight, because we also have the weight of the box. And we take all the distances from the pivot. So for the weight of the box, at least the larger box, which is 0.43, so 0.43, we are going to use the formula for moment, F into D equals to F into D. So this is trying to cause a clockwise rotation, and this would be trying to cause an anti-clockwise rotation, according to the pivot at least. So 0.43 multiplied by distance, how are you going to find this out? You see, this is actually 6. 6 minus 2.4 is going to give you 3.6 for this one. So how far away is it from the pivot? It's 3.6. This is 3.6. Let me erase the rest of them so that it becomes clear a bit. Okay. All right. So we figured out the anti-clockwise. Let's figure out the clockwise. So how far away is the sphere from the pivot? So you see, this is the pivot. This is the table edge. And this is the sphere where it is placed. I'm just zooming it in. So this whole length or diameter is 2.4 centimeters. Its weight appears at the center. So it should be half of this. It should be 1.2 centimeters away from this edge, which is been called the pivot. So it will be W multiplied by 1.2 at least. So when you find W, it's going to be 1.29 newtons. To convert this into mass, divide this with 9.81. You will find the value as 0.13 kilograms. Okay, which is going to be option B. Question number 14, very easy question in terms of vector addition. You see, he says that the system is in equilibrium. If this is in equilibrium, what is the mass of the object? No issues. You see, the mass of the object, or at least the weight of the object, should be in the downward direction. What are these two components trying to do? So one of the components is in this direction, and one of the components is going to be in this direction. Again, one of the components is this direction, and one of them is going to be in this direction. If this is in equilibrium, I can guarantee that the right side x-axis will be equal to the left side x-axis. But we will check that later. But first, let's try to figure out the question. So what are the factors that are trying to hold back the weight or from trying to fall it down, or preventing it from falling down, right? So this is one factor, which will be 210. Since the component is in front of the angle, I have a shortcut for this. Use sine for this. If you were calculating this one, it would have been 210 cos of 10. So whatever the angle is touching, it would have been this. Okay, so in front of the angle should be a sine factor. So this is 410 sine of 60. So this factor and this factor collectively are trying to hold back the weight because that is along the y-axis. This is along the y-axis and this is along the y-axis. So simple equation is formulated. So 210 sine of 10 plus 410 sine of 60 equals to mg. When you find out the mass of the system, it comes out as 391. So 391 kilograms divided by 9.81 gives me 39.9 kilograms, which is going to be 40 kilograms up to two significant figures. Now, just a small tidbit over here for you to just verify and check. I'm going to do this for just one of them so that you can fully understand what vector components are actually. You see, if I draw a 90-degree angle at this point, then I can see that this will be 30 degrees. Okay, no problem. Can I use 30 degrees for this situation? Yes, I can. You see, these components in this direction and in this direction represent the same 410 at an angle of 60 degrees as given in the question. You can try this right now. Pause the video, try this 410 in front of the angle. This will be, so this is not required. We require this one. This is touching the angle, so this will be cos of 30. Try right now that 410 sine 60 is actually equal to 410 cos of 30. So it does not matter where you are looking at the components from your perspective. One other thing to try to test over here to further solidify the concept at least would be that check this, that 410 cos of 60 and 210 cos of 10, they will be equal. The left axis and the right axis of the x, they will be equal. That's why the object is in equilibrium, which means along the x-axis and along the y-axis, everything is balanced, right? Okay, question number 15 requires a bit of understanding of the Archimedes principle, but anyways, let's go ahead. It says the cube is made of iron, density 7900. The liquid is a mercury. The cube floats 42% of the volume above the surface of mercury. So it's a 42% out, and I can say that it is 58% in the liquid, right? So he says, what's the density of the mercury? One thing for sure, I can guarantee this before even starting the question, that the density of mercury will be greater than iron. Because if iron's density would have been greater than mercury, it would have sunk. It would have sunk in the liquid, but it's not. That means liquid's density is greater. So option A and B will be rejected. I will not even consider them because I know that they are not going to be the answers. From O levels, at least I remember from the chapter of liquid pressure, for the barometer, when we measure the atmospheric pressure, I remember that the value is 13,600 kilograms per meter cube. So I can by memory recall the answer to be C, but in the interest of science at least, I need to solve this so that this question could have been given for other situation. What would I have done then? So I can't memorize it like this. Okay, so we need to understand how upthrust and this floating principle actually works. This is actually a tussle. This is actually a race. This is actually a fight between two systems. You see, the liquid, the solid object is trying to, penetrate through the liquid, but the liquid is trying to hold it back. But how is it doing so? You see, the weight of the whole box on one side, the solid one. This is the solid block. Whatever mass, whatever weight it may have is on one side. And the liquid that it has displaced. What is the liquid that it has displaced? Let me shade this for you. So the amount of liquid that this solid object, while it came in, has displaced is actually this much. So 58% of the volume, at least this way, of the water, sorry, not water, but liquid, is in a race, is in a tussle with this solid object. It's not allowing it to come in, right? So there is a balance between them. Since it's in equilibrium, that means whatever the mass, whatever the weight is of the solid is actually equal to the weight, at least, of the liquid it tried to displace. This is what is upthrust, right? So let's try to see what's happening. So the force generated by the solid is equal to force generated by the liquid. What is the force generated by the solid? That is actually equal to its weight. Now notice that all of the solid is involved in pressing down into the liquid. So if I take the liquid, if I take the volume of the solid to be V, then to find the mass, what I can do is multiply simply. Density is equal to mass over volume. Take volume over the other side, I get mass equals to density divided by volume. So, this will be mass equal to density multiplied by volume. So this will be rho V into G equals to, what's the density or what's the force by the liquid? How much liquid has been displaced? 58% of the liquid has been displaced, right? So this will be the density of liquid into 0.58 times volume into G. Again, another perspective to look at this. This is 58%, just 58% of this dense liquid was good enough to hold back 100% of the volume of the solid block. If it was good enough, it won't let it to come inside, it won't let it to penetrate any further than this, which means that now they are in a state of equilibrium. I can equate them. So V gets cancelled out, G gets cancelled out, we are left with just values. So this is 7900 equals to rho L into 0.58. So rho L comes out as 13,600 as my initial guess, because I remember this from O levels. Again, we don't have to do that. We need to understand how buoyancy, how Archimedes principle, how these things work, right? Okay. So pressure due to liquid or Archimedes principle was rho G V, volume, right? So this is what has been replaced over here, rho G and V. What volume was required to balance it out? 58% is holding back 100% of the solid, right? Again, a straightforward question. We understand that in terms of liquid, the formula rho G H does not care about the fact what's the shape of the container. If the container is thin, whether the container is thick, it does not matter. Rho G H has no variable representing the shape of the container. It does not care. So he says that the density, the liquid vessel P is twice as dense. So this is 2 rho and this is rho. Comparing the pressures, so P with Q, no issues at all. Rho G H, rho G H. Rho G H will cancel, so it is 2:1. And he says that the height or the depth at least is same. So even H cancels out. Okay, all right. So we understand that it's going to be option A at least. A motor lifts a load of this much, load W. He says expression gives the time taken for the power to lift. Okay, no problem. So we have the formula for power, which is power is equal to work done divided by time. And we know that the weight is actually a force. It has been lifted, let's say, up to a distance d, for example. From surface, it has been lifted up to a new distance, which is distance d. So work done will be actually F into d. Now in place of F, I can write down W into d because it's the weight that you have to at least lift. Divide by t. Let's take t on the other side and bring p over here. So time is equal to work multiplied by distance divided by p. So this very closely resembles the option C. A lamp is switched on for 2 hours, no problem. The power input is 1 watt. The energy output is 7,000. So I recommend for these questions, make an efficiency box to make things, or to at least make life easy for you. He has given you the output. The useful output of the bright lamp is 7,000. So 7,000 was the output that you required. He says that the input power is 1 watt continuously for 2 hours. Now, since all the answers are in joules, I need to convert everything into joules as well. Let's convert this 1 watt into 2 hours, or using 2 hours into energy. So power is equal to energy divided by time. 1 equals to E divided by T. Now remember, everything has to be converted into seconds. This is 2 hours. So 2 multiplied by 3,600, I guess. Yep, 3,600. If you take the over there, this is going to become 7,200 joules. So you've invested 7,200 joules and you only got back 7,000 joules of useful output light energy. He says how much energy is converted to other forms, or other forms you can say wasted. How much has been wasted? 200 joules has been wasted. Who gives us the license to think like this, like an accountant, that everything is accounted for? If I've given 7,200 joules, if I add every energy or every ounce of energy on the output, this will still become 7,200. Who gives me the authority to use this logic? Law of conservation of energy, right? That is the license I have. Question number 19. He says, which has no atmosphere? Okay, fine. Air resistance is negligible. When he says no atmosphere, drop down. Okay, all right. So there are two situations in which there is energy and there is a height. What's happening in terms of y? What's the g of y? So this is going to be simple algebra. So in terms of at least gravitational potential energy, I realize that delta E will be calculated if I use the formula mgx thrown from a height of 3 meters. So I get that delta E is equal to 3 mgx. Okay, fine. This is my equation number 1. Let's formulate this for the second one, which is the planet Y. So for planet Y, I have 4 times delta E equals to mgy into 4, which is height. You see, mass was same mass is being dropped on both surfaces. That's why the letter m is going to be the same. So I realize that delta E is equal to gy into nothing, I think. Yeah, sorry, this is going to be this way. So mgy, because 4 is going to get cancelled from both sides in terms of mathematics at least. So replacing this, or at least equating both of them, this is equation number 2. Let's equate both of them. I get mgy equals to 3mgx. Very simply straightforward. I can see that m gets cancelled out. I'm left with just simple equation that says that gy is equal to 3 times gx. Very straightforward. C answer. All right. And another thing would be that I can see that its g is greater. You see, it had to fall 3 meters, a very large distance, to just observe a change of, let's say, 100 joules. But if it falls a distance of 4 meters, it experiences a change of 400 joules. So I can say 100 joules per meter. And over here, this is approximately 3 times less, only because its gravity is 3 times less. Okay, all right. A known tensile force, limit of proportionality. When he says limit of proportionality, that means Hooke's law will be followed. So you can imagine that it's going to be a straight line like this. To measurement to enable strain of the stress over strain. Strain has the formula of change in length divided by original length. And the very straightforward answer of this would be, I need to measure the unstretched length, which is original length, and the extension, which is delta x. I can find strain. All the other options do not give this answer. Question number 21 requires a bit of mathematical manipulation. You see, since this is a curved graph and it's about Hooke's law, if I write this equation f equals to kx, I can see that f and x are linearly related. There is a power of 1 for both of them. So this is actually a proportionality like this. It should have been a straight line if I look at option B and C, but it's not. Force and extension should make a straight line. So B and C will be cancelled. We will not even look at them. Now let's move to question number, part number A and D. What could be the respective quantity? You see, if x would have been extension, let's say it's E, right? And plus elastic potential energy would have been on y, which is ek. I understand that the elastic potential energy has the formula of half kx squared. So they're both linked by a non-linearity, which is being proportional like this, right? So if this was the case, then this graph should have been like this. It should have gone like this, but it's not, which means that it's the opposite way around. They're connected in the opposite direction. Now, if you're confused about this one, please go back and revise that y is equal to x squared makes a parabola, at least starting from the origin at least, right? So it should have been like this if it was the option D, but it's not. It's going to be option A. So we have elastic potential energy Ek over here and the extension x squared at least over here. Okay, all right. So question number 22 requires a bit of understanding as well. One thing that you misunderstand about this question is that he has tricked you into this one problem, and that is that in all the options, time is advancing in this direction. For example, this is t1, this is 1, this is 2, this is 3, 4, 5, and 6. Time is moving in this direction. But in the question, time is reversed. Why? Because first, P is going to encounter this point. So it will be at time t equals to 1 second. Then P encounters this, let's say it is at 2 seconds. Then P encounters this stage at 3, 4, 5, and 6. So time is moving in this direction over here. So an easy way to look at this would be to just flip this, at least in your own understanding. You see, he is going to follow, he's going to, observe this first, then this, and then this. So can we find this somewhere else? Can we find this in graph? You see in option A, it encounters nothing. Okay, there is no change. All right, there is no change, but immediately the displacement becomes 0. No, it should have become positive. P is moving upwards. So option A is rejected. No time, no use wasting more time. Part B. Okay, fine. P moves up, right? So this is 1, this is 2. P goes up after 2 seconds. Okay, fine. But then it maintains a certain height. It should maintain a certain displacement. It fails to do so. Option B cancels out. Coming to C part, again, in C, we realize that it should go towards a positive displacement after passing at least 2 seconds. It's going towards negative displacement. This option cancels out. Now, D is the correct answer. How to visualize this? You see, always look at it from the perspective of time. This is time. So time is advancing in this direction, and in option D, time is advancing in this direction. This is 1, 2, 3, 4, 5, 6. So first we realize that, at least for the first part, that P should move up. It should go towards the positive displacement if it has to exist. So P goes to the positive displacement. Okay, fine. Then from 2 seconds up to at least 5 seconds or 4 seconds, it maintains a constant displacement with its positive. So from this point to this point, maintains a constant displacement. Then its displacement comes down, becomes 0, and goes to negative up to 5 seconds, let's say. Same thing happens over here, right? And then it continues its life up to 6 seconds, continues its life up to 6 seconds. I've just flipped this graph given in the question the right way around, so you can relate to it in terms of at least timestamps, which becomes easy to understand now. Okay? All right. So question number 23 is based on memory. We understand that progressive and longitudinal waves are correct. He's going to give you multiple statements. Let's discuss the problems with everyone. Particles in transverse wave have fixed equilibrium positions. Not always, but longitudinal waves do not. This is wrong. They do have a fixed position, and even longitudinal ones have different, do have positions. Waves is correct. Now there is a problem. The problem is that the positions are not fixed. You see, they are always moving upwards and downwards, and in longitudinal they're moving forward and backward. So this is wrong. Part B, transverse waves can be polarized, longitudinals cannot be polarized. This is also correct. So this would be the correct answer. The rest of the two you can pause the video and see are incorrect, factually incorrect. Okay. Question number 24, he says that there is a person standing in a window, for example, or leaning outside the window. There is a pot, for example, or at least a speaker that produces sound. He accidentally throws the speaker, or the speaker is actually falling down right now. Okay. Now, when it has fallen a distance of 10 meters, it produces a sound of pulse 256 hertz. He says, what is the person going to observe? You see, the source of sound is moving away, so the frequency should decrease. I should see a decreasing frequency or observe. But first we need to find out the speed at this point so that we can use the formula for Doppler effect. How to find the speed? We can simply use the equation v square equals to u square plus 2as, and we understand this is going to become v under root 2gs. So v equals to under root 2 into 9.81 into height was 10. Velocity comes out as 14 meters per second. So now we apply the Doppler effect formula. So Doppler effect will be the standard frequency 256 multiplied by the speed of sound, which is given to us as 330. So 330 divided by 330 plus 14, the speed of the object itself. This gives me an answer of 245.5, which is 246. Question number 25 is based on memory. I can't help you in this. You'll have to memorize all of this. You'll have to memorize this table. You'll have to memorize these wavelengths and lambdas. There is one trick about this. What students generally do is they know that the speed of light is 3 into 10 raised to the power 8 meters per second. So they remember only one side, either frequency or either wavelengths of these respective spectrum. So they calculate this on spot using v equals to f lambda. So if this is 3 to 10 raised to the power 8 equals to f is what we don't know, or if this is what you've memorized, you pick up the wavelength 5 into 10 raised to the power minus 2 and you calculate the frequency, and it will be something familiar that you've already learned or memorized. Now there's a problem with this technique. What if he had given you the frequency in this question and you've come prepared by memorizing the wavelengths? What would happen then? So There is no shortcut for this. Always be advised, this question is going to get repeated again and again. This will be a part, so please memorize this table from your books. Question number 26, he says, what's the minimum requirement for at least measuring loud spots, sound intensity? And this is probably a question, this is about stationary waves. Okay. Which row is required? Frequency of sound. Frequency is not required because what he wants to do, he wants to measure the wavelength. Yes, wavelength. So we know that in stationary waves, the wavelengths are measured or can be measured by the distance between nodes and antinodes. This is, let's say, node, this is node, and this is antinode. If this is being measured, or if this is measured, then we can find the wavelength very easily and conveniently. So do we need the frequency? No, we don't. So the rest of the options don't even matter, but let's, for the sake of discussion, the separation between quiet spots, okay, the speed, no, speed is not required because we need to find the wavelength. It's a physical quantity that is measured. You see, the quiet spots are actually the nodes. If I know the distance between the nodes, that is actually half the wavelength. So if I know the distance between the nodes or respective nodes, I can simply multiply this with this. I will get the distance or at least the wavelength. It will be measured easily. Then I have the question for superposition. He says that there are two waves. He says, what's the displacement at 0.38? Be very careful. Just simply take the displacements or instantaneous displacements at these locations. Be advised to fully count the boxes at least, or properly count them. There's going to be this box and it goes up to this point, which is going to be 0.2 perhaps. And this is going to go up to probably, yes, up to this point. And this is actually going to be minus 1.2. So if I add them together, what will be the result of displacement? So this will be 0.2 plus minus 1.2, giving me minus 1.0. So my answer will be option B. It was a question of superposition. Question number 28 requires what situation diffraction occurs? Wave bounces back. This is simply a reflection. Passes to another medium. This is a refraction, change of medium. C part through a gap. Yes, narrow gap. This is diffraction. Identical, so superimposed. This is interference. So again, diffraction is only option C. Question number 29. He says that it's a double slit experiment. So the formula that I'm going to use is AX equals to lambda D. Always remember to write down the formula beginning the question. He says that it's 2 meter away. This is D. The separation is A. And the distance between the bright fringes is 8, which is going to be X. He says, what's the distance between, or what's the path difference? To understand the path difference, we need to find the wavelength. We can't do it without it. So let's find out the wavelength. So A was 0.1 into 10 raised to the power minus 3. Please, for God's sake, be advised, this is millimeters, so convert this into meters. X is 8 millimeters, so 8 into 10 raised to the power minus 3 over here. Then divide this with D, because D goes over there to division, for division. So this is 2. And the lambda comes out as... I think it's 400, yes. So this is 4 into 10 raised to the power minus 7 meters, which can be written down as 400 nanometers, just for the sake of understanding at least. Okay, so he says, what's the distance mean separation? Okay, path difference up to the second order dark fringe. Let's zoom into the question and see, and let me discuss a shortcut for you. What is the wavelength, or at least the path difference at these points? You see, at the very central point, the path difference is 0. The path difference is 0. So at 0, at this point, the path difference is going to be 0 lambda. At the very first dark fringe, the path difference will be 0.5 lambda. At the very first bright fringe, the path difference will be 1 lambda. At the very second dark fringe, the path difference will be 1.5 lambda. I hope that you see the pattern over here. So this is going to be 2 lambda. This is going to be 3 lambda. This will be 2.5 lambda, and so on and so forth. And it goes at both sides. Goes here as well. Now this is its path difference. Let's talk about the phase difference. What will be the phase difference? Easy to find. So at 0, this will be 0 degrees. At the first, it will be 360 degrees. At second, it will be 720. And at third, it will be 3 multiplied by 360. What's going to happen at this point? So this is 180, and all the consecutive ones will be simply found by adding 360 into it. So you can find out the phase difference of these waves as well. What is this actually, by the way? What is this? You see, when waves actually occur, or at least come from two sources, let's say this is one source, let's say it goes to this point, and this is the other source that goes to this point. What happens at the last moment? One has a crest, one has a trough, it is going to cause destructive interference. If one has a crest, the other has a crest, it was called constructive interference. If one has a trough, the other has a trough, it will again call for constructive interference. Because we can't visualize it again and again, this is the method that we've devised to figure out whether it's constructive or destructive. So since the second order is at least 2.5 wavelengths away, second order, yeah, this is 1.5 wavelengths away. So 1.5 lambda is the path difference. So 1.5 multiplied by 4 into 10 to the power minus 7, which you found in the previous part. So this is going to be option C. Simply, we can see that 1.5 into 4 is 6. We don't even need a calculator for this. Question number 30 was a tricky question, but it's a nice question. It's good. Okay, so red light is shown. Okay, right, fine. So this is a diffraction grating crystal in which the formula was n lambda equals to d sine theta. So center is the 0 order, side is first order, this one is second order. Again, this is first and this is second order. Okay, right, fine, very good. Now, how to visualize this? You see, if you do the diffraction of just one color, this is what you will see. Just one color being deviated from different paths. He says what's going to happen if you shine a bright white light. The red light is replaced with white light. Now, white light actually diffracts and opens up or disperses into 7 different colors. Now, they are not exactly 7. We just say that to make it easy. Now, what is going to be the output? You see, if you go back over here, this is what the pattern of white light looks like. At the very center, we see a white light, but on this, if you move away from that, the first order shows that it starts from violet and ends at red. Again, the second order starts at violet, ends at red. This is what it looks like in real life, this animation. You can see that at the very center, it's a bright fringe, but as you move away, you can see that it shows that the very first color that you see is actually violet, and the last color that you see is actually red. So, and it spreads out as well. It has spread out along this band, right? So if I go back to the question's options, option A and B were incorrect, because if it was white light, they would have spread out into at least 7 different colors, which they are not showing, so which means that this is not the answer. Let's try option C and D. You see, I know for a fact by this understanding that the first color that I will see is violet, the last color that I see is red. So if I come back to this position, I realize that in C and D both, the starting color should be violet, the ending color should be red. Starting color should be violet, the ending color should be red. This is what I've learned. If I compare this with the original diagram, this is what I realized. If you use a ruler, you will realize that if you draw a dead straight line through this, the only place where you can see that red light is going to exist is option D. You see, if I compare this with option C, I realize that this is the start of the spectrum. This should have been violet. This color shows that this is red. Wrong. It should have been at the end. So if you extend, I'm unable to do so without a steady hand. Okay, so I've been able to do this for this one. This is where I should see red. Yes, this is where I should see violet. So the correct answer was D, according to this spreading out of waves or the dispersion of white light through diffraction grating crystal. Okay, all right. Moving on to question number 31, simple electricity question. He says, to find out the average drift velocity, we have the resistance, we have the voltage. So we can find the current as well. The current formula is NAQV, which is also equal to voltage divided by resistance. So simply putting all the values in this equation, this becomes N is the charge density, which is 9. Let me zoom in a bit. Which is 9, right? So 9 into 10 raised to the power 28 into the cross-sectional area is also given to us, probably, I think, in the question. Is this given to us? Yeah, it's given to us, the diameter, okay. So pi into 3 into 10 raised to the power minus 3 divided by 2 whole square. So this is the cross-sectional area. Charge has a constant value of 1.6 power minus 19. V is what we need to find out, equals to V divided by R, voltage divided by resistance, which is 6 divided by 15. So if you want to calculate this further, so this is going to be 0.4 amperes, then you can put it here and then calculate the velocity. Is up to you. You want to perform algebra in step by step, that's your choice. So please be advised that this is going to be squared and this is in millimeters. This will be converted into meters by dividing this by 1000, or at least adding the prefix of -3. When you're done solving this question, your answer is going to be 3.93, which is going to be option B. Question number 32 says that compare the power, the total power dissipated now. So if this had been the case, if this is the EMF and this is the resistance, the original power, the P0, would have been E squared divided by R. Okay, fine. Let's compare with the second case. Since they are in series and the resistors are identical, that means that the EMF has been divided as E by 2 and E by 2 on both of them. Now if I calculate the power of just one resistor, that would be E by 2 whole square, according to the formula P equals to V square over R. E by 2 whole square divided by R, this comes out as E square divided by 4R. If I compare this with this one, this becomes 1 over 4 E square by R. So this becomes 1 over 4 P0. If this is the power for the first one, 1 over 4 P0, then this will also be 1 over 4 P0. The total power will be 1 over 4 plus 1 over 4 as P0 divided by 2, which is option B. Question number 33 is about filament lamp. We understand that if the potential difference is increased, which statement is correct? So if the potential difference increases, the current increases. If the current increases, the heat increases. If the heat increases, the resistance increases, and the respective change in current starts to decrease. It stops increasing, or it stops experiencing an increasing current based on the increase in voltage. So the resistance of the lamp increases. Yes, it increases. It does not decrease. Option A and B are immediately rejected because the temperature decreases. No, the temperature increases. So the resistance of any ohmic or non-ohmic conductor is proportional to temperature, except the thermistor, which has an inverse relationship with temperature. But of course, this is a non-ohmic conductor, and this is only one case we have to memorize. This question number 34 is interesting. I'm going to erase this space because I'm going to need it. He says that the standard values are, and we have all the answers in terms of R, so no need to worry about actually calculating this. He says the diameter decreases to 94% because previously, if it was 100%, it gave you a cross-sectional area of A. And we know that cross-sectional area is equal to pi R squared, which is equal to pi D squared by 4. So the relationship between cross-sectional area and diameter is of a square, A proportional to D square. So if I make the table, for example, then cross-sectional area ratio diameter at 1, it was 1. But if I reduce this to 0.94, if I take the square of this to go back to area, I realize that this comes down to, or if you take the square of 0.94, it comes down to 0.8836. What does that mean? It means that originally if the area was 1, now it has come down to 88%. Just reducing the diameter by 6%, the area has reduced to 88%. He says that the volume is unchanged. This is the interesting part. If the volume is unchanged, then what happens to the volume of a wire? How do we calculate this? We have a cross-sectional area and we have the total length. If I multiply both of them, I get the cross-sectional, I get the total volume. Now I have established that I have reduced the cross-sectional area by, or up to 88% like this. What should I do with length? How should the length have changed so that this would have been compensated? So my mind tells me that I should divide this with a similar number, 0.8836, so that when I actually calculate this, I end up with the same answer. You see, this will be cancelled with this, and I'm going to end up with AL again, which was my original volume. Okay, seems plausible. Fine, it's okay. So the equation that I'm left with is 0.8836 times the cross-sectional area, and multiply this with, if you take the fraction of 1 over 0.8836, this comes out as 1.13 times the length. It means the length would have increased by 13%. Looking at this, 13% to compensate for a decrease of 6% in the diameter, all in the interest of making the volume constant. So if cross-sectional area decreases, the length has to increase proportionally, right? So what is going to be the formula now? So rho R is equal to rho L over A. What have you done to the length? You have increased the length by 1.13%. You have decreased the area by 6%, to 88%. times A. So 1.13 divided by 0.8836 multiplied by rho L over A, which was our original rho L over A. So this comes out as 1.28 times R, which is option D. Question number 35, he says, you can read the question. He says that the EMF is 3 volts, 4.7 is in the inside, 9.3 on the outside. What's the power dissipated in internal resistance? No problem. Let's find out the voltage across that component first. So the internal resistance is 4.7. Applying voltage divider, this is 4.7 plus 9.3. No need to find the current. The voltage that they're sharing is 3 volts. So the voltage across 4.7 comes out as, by the voltage divider, just a moment, it comes out as exactly 1 volt. Nice. So this is 1.0 volt. I need to find the power, which is going to be V square over R. So P equals to 1 square divided by 4.7. So this power comes out as 0.212. If you use full values of this equation into this formula, you will get P equal to 0.2158, which rounds off to 0.22, which is option A. Even though if it was 0.21, you would have selected option A because that is the closest one, and you know that conceptually you've done it correctly. You could have done this question with the current method as well, but it would be, in my opinion, it would be longer. In my opinion, voltage divider is better and faster. This question is from the topic of null method and Wheatstone bridge. Wheatstone bridge is not explicitly mentioned in your syllabus, but I've covered this in an AS level video of circuit analysis. Please don't forget to check it out. Okay, so if you want to learn more about it. Okay, so 15 volts, he says, what's the potential difference in the voltmeter? You need to realize that voltage, back to the basics, is work done by charge, which is joules per coulomb, right? It's the energy of that volt, it's the energy of the electron. Simply put, it's the joules, it's the energy of electron. It's going to be consumed as it passes through the circuit. So it means that when the electron reaches at this location, it has 15 volts to spare. Similarly, when it reaches this junction, it has 15 volts to spare, and when it comes down out of this branch, it has 0 joules per coulomb or 0 volts. 0 joules per coulomb or 0 volts. So it has to disperse its energy in the circuit. To quickly solve this, we're going to use the voltage divider rule for this volt, for at least this resistor. This is going to be 24 divided by 24 plus 6. So the voltage is being divided between these two components because they are in series. Okay. So this comes and multiplied with this with voltage of 15. We get an answer of 12 volts for this. What does that mean? It means that it received an electron of 15 volts. It consumed 12 volts for itself and is only left 3 volts of budget for the next resistor that is incoming, according to the potential divider. Let's calculate for this one. So 6 divided by 6 plus 9 multiplied by 15, we get an answer of 6 volts. What does that mean? It means that when this electron entered, it had 15 joules. 6 volts have been consumed by this resistor, and remaining voltage are 9 by 15 minus 6 at this spot. So it has 9 volts. So what does the voltmeter do? It checks the voltage or received on both ends and tells you the difference. So one end receives 9 volt, one end receives 3 volts. From this, the potential difference is 9 minus 3, which is 6. Option B is the answer. Question number 37. Resistances are not given to you. A generic answer is given to you. At the very beginning, the resistances were equal. So this was R and this was R. And it was consuming 10 millivolts and it was also consuming 10 millivolts. Why? Because resistance is proportional to voltage, and voltage would have been equally divided. Now, he says that a few circumstances have changed. So what has happened is that the new circumstances have called for this resistance to become 2R and this to become 0.5R. He says, what's the new voltage? No problem. Apply the voltage divider rule. If you want to find the voltmeter reading, so the resistance of which you want to find the voltage comes in the numerator. The rest of the circuit comes in the denominator, including the resistor that you were trying to find as well. Multiplied by 20 millivolts. So no need to worry, R gets cancelled out. I've assumed it for myself. No problem. So 2.5R multiplied by 20 millivolts. What are we left with? We are left with the R gets cancelled. 0.5 divided by 2.5 multiplied by 20. This answer comes out as 4 millivolts. So this is option A. Okay, that's why I'm telling you again and again that voltage divider rule is very useful in these circuits, helps you so quickly solve the question. He says 38, alpha scattering experiment based on memory facts. He says what cannot be understood, what cannot be drawn. Atom is mostly empty space. This is one of the conclusions because 99% atoms pass straight through. So depicting that it's empty space. Most of the mass concentrated. This is because one of them was deflected back. This is also deduced. The nucleus contains protons and neutrons. This could not be deduced. Why? Because they only realized that alpha particle comes close to it and gets deflected. What's inside it, we didn't know. We realized that it does have a positive charge. But can we guess that there would have been a neutron which has no charge on it? No, we could not have guessed it. Right? So this conclusion is what was not concluded from the alpha scattering. Nucleus is charged. Yes, we know it's positively charged because it was deflecting the alpha particles in the opposite direction, or at least trying to change their path. So it can only be done, it could only have happened if the charge at the center was exactly the same as of alpha particle. Which particles are opposite charges? Alpha and helium are exactly the same. Beta minus and proton and electron exactly the same. Positron and proton exactly the same charges. Beta plus and antiproton, these are opposite to each other because proton has a positive charge but antiproton will have a negative charge. Beta plus has a positive charge which is called positron. Lepton family is a positron, electron and neutrinos, right? So neutrinos and antineutrinos belong to the family of lepton. The other family is hadron, is a part of your course. Hadrons have two further families. The first one are baryons and the second one is mesons. Meson made of two quarks. Hadron are basically made of quarks. Leptons are not made of quarks, they're made of neutrons, neutrinos, electrons. This is basically a memory-based question. And baryons are made out of three quarks. This is special about this one. Mesons are made out of two quarks. One quark and one anti-quark of this one. This is again a special part for mesons, right? Okay.